Today's session is about the least cost method. It is one of the methods to solve transportation problems, which is seen in operation research. Least cost method is a method to find a feasible solution to a transportation problem. Transportation problem is a special type of linear programming problem, LPP, in which goods are transported from one set of sources to another set of destinations based on the supply and demand of the origins and destination, respectively, such that the total cost of transportation is minimized. Transportation problems are of two types. Balanced transportation problem where both supply and demand are equal. Unbalanced transportation problem where supply and demand are not equal. In this case, it has been converted into balance format by adding a dummy column or row. If demand is more than supply, then add a dummy row with cost 0 and supply equal to demand minus supply. If demand is less than supply, then add a dummy column with cost 0 and demand equal to supply minus demand. Approach. Step 1. Check whether supply and demand are balanced. If unbalanced, demand is not equal to supply, that is, if demand is more than supply, then add a dummy row with cost 0 and supply equal to demand minus supply. If demand is less than supply, then add a dummy column with cost 0 and demand equal to supply minus demand. Step 2. Select the minimum value of transportation matrix and assign minimum value of supply or demand. Step 3. Subtract the above minimum value from OI and D of the corresponding row and column. Here, we may get three possibilities, as given below. 1. Supply is equal to 0, then strike that row and move to cell with next minimum value. 2. Demand is equal to 0, then strike that column and move to cell with next minimum value. 3. Supply is equal to demand is equal to 0, then strike both row and column and move to cell with next minimum value. Step 4. Repeat these steps until all the supply and demand values are 0. Step 5. Calculate the total minimum cost using the quantities and allocated values. Let us understand this clearly with examples. First, we shall understand how to solve balanced transportation problem. Example: obtain the feasible solution of the given transportation problem using least cost method. Transportation problems are given in such tabular form. Here origin and destination are given along with supply and demand. Our objective is to transport the quantities from origin to destination in the way to reduce the transportation cost. Solution: this is the table. Step 1. Check whether supply and demand are balanced. So here we must calculate total supply by adding these 7 plus 9 plus 18, which comes to 34. Similarly, we must calculate total demand by adding these 5 plus 8 plus 7 plus 14, which again is 34. Hence here we see balance of supply and demand. Step 2. In least cost method, here this 8, this is the least of all the values, hence we will start from here. Here supply is 18 and demand is 8, 8 is less, so 8 is minimum value assigned. Here 8 minus 8 becomes 0. Here 18 minus 8 is 10. Since demand becomes 0 here, this column is cancelled. Now we move to the cell with next minimum value. 10 is the next minimum value between 7 and 14. 7 is less, so minimum value assigned is 7. Here 7 minus 7 is 0 and here 14 minus 7 is 7. Since supply becomes 0, this row is cancelled. Now we move to the cell with next least value. This cells with the next minimum value 20, between 10 and 7. 7 is less, so minimum value is 7. 7 minus 7 is 0. 10 minus 7 is 3. Demand becomes 0, column is cancelled. Now we move to the cell with next least value. We see two cells with the next minimum value 40. We can choose any one. We are choosing this one, between 7 and 9. 7 is less, so minimum value is 7. 7 minus 7 is 0. 9 minus 7 is 2. Demand becomes 0, column is cancelled. Now we move to cell with next minimum value. This 40, here 3, here 5, minimum value is 3, 3 minus 3 is 0 and 5 minus 3 is 2, supply is 0, so row is cancelled. Now we move to cell with next minimum value, which is this, 70, here 2 and here also 2, minimum value is 2, 2 minus 2 is 0, supply and demand are 0. Next step is to calculate minimum feasible transportation cost. These are quantities and these are allocated values. Calculate the total minimum cost of transportation by adding the product of the above values. Here, the number of allocated cells is equal to 6 is equal to m plus n minus 1 and allocated cells are independent, hence solution is non-degenerate. Total minimum cost is equal to 2 times 70 plus 40 times 3 plus 8 times 8 plus 40 times 7 plus 10 times 7 plus 20 times 7 is equal to Rs. 814. Let us understand how to solve unbalanced transportation problems. Example: obtain the initial feasible solution of the given transportation problem by using the least cost method. Solution: this is the table. First, 1. Check for balance of supply and demand. Total supply is equal to 15 plus 24 plus 21 plus 42 is equal to 102. Total demand is equal to 6 plus 27 plus 54 is equal to 87. Demand is not equal to supply. Here, demand is less than supply, so add a dummy column with cost 0 and demand equal to supply minus demand. Demand is equal to 102 minus 87 is equal to 15. Step 2 in least cost method. Here we need to select the cell with least value. All these cells have least value, 0. We can choose any of these cells. We choosing this one, hence we will start from here. Here supply is 15 and demand is also 15. So 15 is minimum value assigned. Here 15 minus 15 becomes 0. Since demand and supply becomes 0, here, this row and this column are cancelled. Now we move to the cell with next least value. We see two cells with the next minimum value too. We can choose any one. We are choosing this one. Between 42 and 6, 6 is less, so minimum value is 6. 6 minus 6 is 0. 42 minus 6 is 36. Demand becomes 0, column is cancelled. Now we move to cell with next minimum value. This too, here 24, here 54, minimum value is 24. 24 minus 24 is 0 and 54 minus 24 is 30. Supply is 0, so row is cancelled. Now we move to the cell with next minimum value. 4 is the next minimum value between 36 and 30. 30 is less, so minimum value assigned is 30. Here 30 minus 30 is 0 and here 36 minus 30 is 6. Since demand becomes 0, this column is cancelled. Now we move to the cell with next least value. We see his cells with the next minimum value 8, between 21 and 27. 21 is less, so minimum value is 21. 21 minus 21 is 0. 27 minus 21 is 7. Supply becomes 0. Row is cancelled. Now we move to cell with next minimum value, which is this, 12, here 6 and here also 6, minimum value is 6, 6 minus 6 is 0, supply and demand are 0. Next step is to calculate minimum feasible transportation cost. These are quantities and these are allocated values. Calculate the total minimum cost of transportation by adding the product of the above values. Total minimum transportation cost is equal to 2 times 6 plus 12 x 6 plus 8 times 21 plus 2 times 24 plus 4 times 30 plus 0 times 15 is equal to 420 rupees. The number of allocated cell S6 is less than m plus n minus 1, which is 7, so the solution is degenerate.